Dear students, welcome to the course Basic Geotechnical Engineering, Module 3, Flow Through Soils, Session number 7. I am Raja Anwar Hussain, Assistant Professor, Government Engineering College, Raichur. So in this session, let us solve some problems on flow through soils, that is based on the coefficient of permeability based on the laboratory methods, constant head method and variable head method. So let us see in this problem, calculate the coefficient of permeability of a soil sample 6 cm in height and 50 cm square in cross sectional area if a quantity of water equal to 430 ml passed down in 10 minutes under an effective constant head of 40 cm. On oven drying, the test specimen has a mass of 498 grams, taking the specific gravity of soil solids as 2.65. Calculate the seepage velocity of water during the test. So here, as per the given problem, a soil sample 6 cm in height and 50 cm square in cross sectional area. So now let us see. So the given data, Q is equal to 430 ml and time small t is 10 minutes. In terms of seconds, that is 600 seconds. So the area is also given 50 square centimeter and length of specimen as 6 centimeters and head 40 centimeters. So this problem is a constant head. So let us take the equation for constant head. That is K is equal to Q by T into L by H into 1 by A, where Q is equal to 430 divided by 600, whereas L is 6 and H is 40 and 1 divided by A is also given 50. Dear students, do the calculations. So if you solve, the answer will be 2.15 into 10 to the power of minus 3 centimeter per second. So if you want in terms of meter per day, then one centimeter per second is equal to 864 meter per day. So now 2.15 into 10 to the power of minus 3 into 864, which will be equal to 1.86 meter per day. So we need to calculate seepage velocity, that is Vs. Now V is equal to Q by A 430 divided by 600 into 50, which is equal to 1.435 into 10 to the power of minus 2 centimeter per second. So here alternatively can also calculate V using V is equal to Ki. This K is 2.15 into 10 to the power of minus 3 and I is H by L, that can be written as 40 by 6. So that is equal to so it is coming around 1.435 into 10 to the power of minus 2 centimeter per second. So now, as per the seepage velocity formula, that is Vs is equal to V by N. So we need to calculate V and N to get the seepage velocity. So N is equal to E divided by 1 plus E. Again E can be calculated based upon the given data, that is G is the specific gravity. So we can use this formula, rho W divided by rho D minus 1. So now what we can do here is rho D is equal to md divided by V, which is equal to, so specimen has a mass of 498 grams, so that mass of 498 grams divided by, that is volume is 50 into 6. So it is coming around 1.66 gram per cm cube. So now this value can be used in equation here. E is equal to G into rho W divided by rho D minus 1, where rho W can be taken as 1. So the equation for E is equal to 2.65 into 1 divided by 1.66 minus 1. So the E value will be coming around 0.595. So now we have the value E is equal to 0.595. So the E value is 0.595. So now we can calculate N is equal to V divided by 1 plus E, which is equal to 0.595 divided by 1 plus 0.595. So here value coming around 0.373. So now we can calculate, we know the values of V and N. So V, it is 1.435 into 10 to the power of minus 2 centimeter per second. So now we can calculate the seepage velocity as 1.435 into 10 to the power of minus 2 divided by 0.373. So now let us see the value. So the seepage velocity is coming around 3.85 into 10 to the power of minus 2 centimeter per second. So this is the final value for seepage velocity, that is coming around 3.85 into 10 to the power of minus 2 centimeter per second. So now let us see some other problems based on falling head permeability test. In a falling head permeability test, the initial head is 40 centimeter. The head drops by 5 centimeter in 10 minutes. Calculate the time required to run the test for the final head to be at 20 centimeters. If the soil sample is 6 centimeter in height and 50 square centimeter in cross section area, calculate the coefficient of permeability taking area of standpipe is equal to 0.5 square centimeter. So here the given data, so here in a time interval T is equal to 10 minutes, the head drops from initial value that is H1 is equal to 40 centimeter to H2 is equal to 40, so by 5 centimeters, it drops by 5 centimeters, so minus 5, so the H2 will be 35 centimeters. So now we have to use the equation for falling head permeability is K is equal to 2.3 AL divided by AT into log to the base 10 H1 divided by H2. Or T is equal to 2.3 AL into AK log to the base 10 H1 divided by H2. So this setup will be constant, can be taken as M log to the base 10 H1 by H2. Therefore, T is equal to M into log to the base 10 H1 by H2 can be written as 10 is equal to M into log to the base 10. H we have here as 40 and H2 is 35. So therefore M is equal to 172.5 units, we will take it as. So now T is equal to 172.5 log to the base 10 H1 by H2. Now let the time interval required for the head to drop from initial value of H1 40 cm to final value of H2, that is H1 was 40 cm and the final value of H2 is equal to 20 cm. Be T minutes. So now T is equal to 172.5 log to the base 10 40 divided by 20. So here T is equal to 51.9 minutes. So now K is equal to 2.3 AL. A into M will take, because M we know that 2.3 AL divided by AK. So here K is equal to 2.3 AL divided by A into 172.5, or K is equal to 2.3 into A is 0.5 into 6 divided by 50 into 172.5. So the value it is coming around 1.335 into 10 to the power of minus 5 centimeter per second. That is K is equal to 1.335 centimeter per second. So now let us see one more problem. That is, during a permeability test on a soil sample with a falling head, permeability permeameter equal time intervals are noted for drops of head from H1 to H2 and again from H2 to H3. Find a relationship between H1, H2 and H3. So as per the given data, so the head drops from H1 to H2, then I'm H2 to H3. So here T1 is equal to T2 is equal to, we can take it as small t. So when we need to find the relationship between H1 to H2 and H2 to H3. So it's a falling head permeability test. So the equation for the falling head permeability test is 2.30 AL divided by 80 into log to the base 10 H1 by H2. So here the head loss is from H1 to H2. We will substitute here. So let us say it as equation 1. Now the head drop is from H2 to H3. So same equation 2.303 AL divided by 80 log to the base 10. So here the head drop is H2 to H3. So now we will consider this as equation 2. Now equating both the equations 1 and 2, So here this it will go so now log to the base 10 h1 by h2 is equal to log to the base 10 h2 by h3. Further the equation reduces to h1 by h2 is equal to h2 by h3. So now what we can do is, in terms of h2, if we want the equation, so we can write it as, if this h2 goes this side, h2 square, then h1 into h3. So again h2 square, if you remove this square, then it will be square root of h1 and h3. So now let us see one more problem. So a pumping test was made in pervious gravels and sands extending to a depth of 15.24 meter. A bed of clay was encountered. The normal groundwater level was at the ground surface. Observation wells were located at a distance of 3.05 meter and 7.62 meter. From the pumping well at a discharge of 260 liters per minute from the pumping well. A steady state was attained in about 24 hours. The draw at a distance of 3.05 meter was 1.68 meter and at 7.62 meter was 0.37 meter. Compute the coefficient of permeability. So now let us see. We have to use the pumping out test formula here. So here the given data. That is Q is equal to Q is equal to discharge is equal to 216 liters it is there per minute it is. So it is coming around 3.6 liters per second, which is equal to 3.6 into 10 to the power of minus 33 centimeter cube per second. So here two observation wells were located at a distance of 3.05 meter and 7.62 meter. So here R1 is equal to, that is the radius of the first observation well from the main well is R1 is equal to 3.05 meter, and R2, that is the radial distance of the second observation well from the main well, it is 7.62 meters. So here H2 is equal to so let us see in the figure. Here it is the main well.